In this video, we're going to continue our discussion on dplyr by talking about its grouping operations. The most basic function here is the function called group by. Group by is going to enable the so-called split, apply, combine strategy of data analysis. The idea here is that we're going to break up a data set, i.e. a data frame or a tibble, into pieces by its rows. We're going to compute on each of those individual tibbles or data frames, and then we're going to re-aggregate the collective back into one big data frame. For example, let's suppose that we wanted to extract the rows of a tibble corresponding to the largest y value for each level of the c variable. Schematically, we have the tibble that looks like this, and I've highlighted the different rows according to their c levels. We're going to break apart that tibble into two different tibbles, which are homogeneous in their c variables. We're going to apply the function that extracts the row corresponding to the largest y value of each of the tibbles, and then we're going to re-aggregate these back together as one tibble. So how would we actually do a computation like this? Well, the first step is going to be to use that group by function. Group by is actually not going to do the computation itself. Group by is going to prime the tibble for the kind of breaking apart and then the re-aggregation at the end, and those are actually handled by the computing functions themselves. Let's see what it looks like. I'll take my tibble and I'll group by C. The result looks like this. It looks very much like an ordinary tibble. The difference is that it printed out with this line that says groups C2. The C there is specifying the variable that it's being grouped by. In this case, we wanted to group it by C, so it's grouped by C. The 2 is saying how many different groups, how many different observed levels were there of that variable in the data set that you're giving it. In this case, there were 2, A and B. Now, to remind ourselves how we're going to extract the row corresponding to the top y variable, remember that we just use slice max. This is one of those new dplyr version 1.0.0 functions. And it's going to give us the row corresponding to the maximum value of y over the entire data set. But what if we wanted to break it into pieces? If we wanted to break it into pieces, we would use tibble, group by C, and then slice max. And the slice max function is smart enough to know that when it sees a grouped tibble, it does its computation group-wise across each of the groups of the tibble that's input. So the result here is actually a 2-row data frame. It's still grouped, and it gives us those top 2 rows that we computed just by hand or conceptually before. Now, structurally speaking, what group by does is it just adds some metadata to the input tibble that actually does the grouping for you. In other words, after we use group by, we still get a tibble back, but it's of class grouped df, so it's a grouped tibble data frame. The columns are actually the same. Those have not changed. But notice now that we have this attribute on it called groups, and the grouping is itself a tibble, and it has 2 columns. Those are called C and dot rows. The C column is telling us the levels of the grouping variable, and the second column is dot rows. It's of class list int, and we'll look at this in just a minute. Now, since the grouping information is an attribute, we can actually just extract it just like any other attribute in the R language by the attr function. But dplyr provides a nice function just called group data that's actually going to extract that for us. It's going to do exactly the same thing. Now, let me draw your attention to that second column again. Remember that we're getting a tibble back, and remember that when tibbles are printed, they're printed with the column type below them. Now, the oddity here is that the column type in this case is called list int. To understand that, we need to have some knowledge of the underlying vectors package. One of the features of dplyr version 1.0.0 and tibble 3.0.0 and moving forward is that tidyverse packages are going to be increasingly dependent on a more basic package called vectors. This is another tidyverse package, and the role of the vectors package is going to systematize all of the underlying features with respect to vectors. Now, when you're just working with vectors that are of atomic type, like integers, doubles, logicals, characters, we know how those operate, and we know that there's a consistent way that they're implemented. There's a hierarchy of types, and there's type promotion and so on when you try to do things like combining them. But once you go outside those 4 atomic types, things generally go haywire. So for example, if you're trying to combine a date with an integer, or if you combine a date with a date time, really strange things happen. And so the purpose of the vectors package is going to make that framework consistent and actually expand type stability to all sorts of other things. More important for our immediate discussion with dplyr, the columns of tibbles are allowed to be any kind of vector. Whether that's an atomic vector of kind of one of the standard type characters, logicals, and so on, or if it's a vector in the vectors package sense. To get a better sense of this, I strongly encourage you to watch this talk by Hadley Wickham. It's short, it's maybe 20 minutes, and it's very illustrative of the kinds of problems that the vectors package is trying to solve. Now, we can actually dig a little bit deeper to see this. If we use per to pluck out that .rows column, we see that the column itself is a list of integer 2. The idea here, of course, is that it's a list, it's of length 2, and it contains integer vectors. If we use the str function on that, we get this. So again, it says it's a list of ints. We know that those ints are going to be the positions corresponding to the A's and B's in the original tibble in terms of their rows. And let me lastly draw your attention to this p-type. P-type is a term that's used in vectors to refer to prototype. It's the prototype of the elements of the vector. Not only does the vectors package provide a consistent framework for thinking about vectors in R, it also provides a means to create new vector types in a basic sense in the R language. Those types themselves are distinguished by a particular prototype. For example, all integer vectors look like an integer vector of length 0. Obviously their size may be different, and vectors deals with sizes too in a consistent way. But at a basic level, the type of the thing is an integer. So when you see p-type throughout the tidyverse increasingly, you should be thinking about the vectors package, and you should be thinking about what that thing is at kind of a more fundamental level. Now, along with group data, you also get a whole bunch of other group functions that help you just understanding a group tibble or extract pieces of it. I'll just go by these really quickly. So we have group indices. That's going to be an integer vector whose length is the same number of rows as the original tibble, and it's going to assign to each row a classification, a grouping, to which that row will correspond. So for example, row 1 had C equal to A, so it's in group 1. Row 2 had C equal to B, it's in group 2, and so on. Next is group keys. This is a tibble that gives you the variable or variables that are grouping the data frame and their values. Group size is going to give you the number of rows corresponding to each of the groups of the tibble, and group vars is going to tell you the variables that are actually being used in that grouping process. You could also use groups. This will give it to you in a list format where the contents of the list, the elements of the list, are individual R expressions. Now, one of the things that you may think about doing with grouping is actually splitting up the tibble by that grouping structure. We know that when you use group by, it essentially just adds attributes, but it doesn't actually do the splitting process itself. If you want to do the splitting process itself, just use group split. You'll get a list of tibbles back, and those tibbles back are the kind of partitioned off original tibble. The idea here probably that you're thinking is, well, I'll just take that and I'll just send it into per's map function, and I'll map a function onto each of those tibbles. And that would be a natural thing to do, but in practice there are much more systematic ways that we do this, coming from the column manipulation video. So wait for that. In the meantime, you should know a few more things. First, when you actually run this, you'll get a whole bunch of printout at the beginning that refers to the vectors description of the group split thing. So you're actually getting a vectors list of class back, and it's telling you the prototype. So the contents of that vector are tibble diffs, they have these columns and so on, and there are 2 of them. Another way to specify this that's a little bit cleaner and more succinct is just take tibble and group split by C. So it's going to take the tibble and it's going to break it into a list of tibbles by the C variable. As I said, what you're probably thinking about is taking the output of group split and piping it into the map function. There's actually functions in dplyr, not even as far as column manipulation, but at this point, that can actually do the mapping for you. The first one that we meet is called group map. So group map is going to be effectively like group split and map. The difference is that you don't split it at all. You just say group map. So you group the tibble and then you group map. Here, the function that I've applied is just the identity function .x, and the reason why I've done that is so that we can see what dplyr is thinking is going to be the input to the function that we're mapping. The result is a list of tibbles, and those tibbles don't have the grouping column itself. They just have the other columns that are corresponding to the data set. Nevertheless, that information is not discarded. To use that, what we would need to do is we would need to refer to a .y, which would create a arity2 function that is mapped onto the data frame. The .y variable is going to refer to the level of the grouping variable. So for example, the function that's going to be applied to the first tibble is going to have .y equal to a, and the second one .y equal to b. Going a step further, once we actually do the mapping process, probably what we're going to want to do is re-aggregate the data back together. That's the combine process. As an illustration of this, let's create a new function. The function is called average x and y. And what it's going to do is it's going to accept a data frame called df, and it's just going to return a new data frame. The new data frame has 2 columns, mean x and mean y, And mean x is going to be the average of the x column of the input data frame, and mean y, of course, is going to be the average of the y column of the input data frame. Now I can use this function in the following way. I'll take my tibble, I'll group by C, I'll group split, so now I have a list of tibbles, and then I'll map with pers map function. And then I'll use pers map function to map the average of x and y onto those tibbles. The result, of course, is going to be a list of two tibbles that are of this form. They're going to have columns mean x and mean y, and they're going to compute the average x and y's for each of the tibbles that are homogeneous in their C value. Of course, what I would want to do next is probably just combine those into one tibble. So I have one tibble, it has columns mean x, mean y, and in kind of back behind this, you'd see a C value, and the C has levels A and B. So structurally speaking, all of this has done with the bind rows, which is kind of dplyr's version of rbind, is to take those original rows and then just reaggregate them back together. So notice that we have explicitly three steps here. We have group split, that's splitting the tibble, map, which is actually applying the function, and bind rows, which is reaggregating things back together. Group modify is going to aggregate those into one function call. So we have tibble group by C, that's going to do the grouping conceptually, but not in actuality. Group modify is going to apply group split on that grouping variable. It's going to do the computation of average x and y, so notice that we have the input function there, and then it's going to do the reaggregation back together into a tibble. The nice part is that we actually don't have to bake the C column into the original average x and y function. We could have done that. We could have done that up here with the group level. So we could have added another column at this point that says C equals group level. But group modify is actually going to do that for us so that we get kind of everything that we want back in one tibble. So this is the split apply combine strategy as far as group functions are concerned. Now I'll note, just because this is a really common case in practice, that usually the way that we would do this is with functions from the column manipulation video, which is going to come next. And the idea is the same, but it's going to use a different function called summarize. And the syntax there would look like this. Tibble group by C, summarize mean x is mean x, mean y is mean y. Obviously, that's a significantly cleaner syntax than having to create a function outside of the mainstream of the function calls, and it will give you back exactly the same tibble you see right here. Continuing on with groups, we have group nest. Group nest is going to create nested data frames. Nested data frames are increasingly of importance in the tidyverse. A nested data frame is a data frame whose columns are list elements, typically lists of tibbles, but they could also be lists of models or something like that. Here's an example. I'll take my tibble, I'll group by C, and I'll use group nest. Notice that the result is a tibble. It has columns C and data. Okay. C, of course, is that grouping variable itself, so that's not very surprising. It has levels A and B. And then we have a vectors element here, list of tibble diffs that have two columns. Those are the parts of the original tibbles that don't have the C column. So this is a nested data frame. Very much like we saw with group split, there's a systematic syntax to do this, which is just group nest. So if I say tb group nest by C, it's going to nest it by C. You should also know that there's a nest function in the tidyr package, as nesting very commonly has to do with tidying a data set. And the result looks like this. Notice that the result is actually a grouped tibble, so that's different than before. It's a grouped tibble, but its contents are the same in a general sense. So there's a column called C, there's a column called data, but now data is of type list, so it's not a vectors list. It's a list in the more basic or the more standard R sense, and its contents are those tibbles. So clearly, tidyr has not yet migrated to the vectors framework, but I think that we can anticipate this in the future. Now, tidyr also has a function called unnest. Unnest is, of course, going to be the opposite of nest. It's going to take a nested tibble, and it's going to unnest those rows. So whenever you unnest something, it gets a lot larger, right? Because we know that this first row has 3 rows in it. We know that the second one has 3 rows in it. So when you unnest things, it expands them, and the resulting tibble typically gets much larger. Now, up until this point, we've only seen grouping by a variable. However, you can also group by the return values of expressions. For example, I could say tibble group by x is less than 2.5. It will actually apply that function to create a new kind of column, as it were, and then it's going to group the tibble by that new column. Notice, of course, that you have this kind of strangely named column that's non-syntactic. That's the expression that you put in. A cleaner way to do this would be to name the expression up front. So here I say group by small x, which is not a column of the dataset, equal to x is less than 2.5. It's going to create a new column called small x, and it's going to group the resulting tibble by that new column. You can also group by more than one variable. Up until this point, all we've seen is group by c, or group by x is less than 2.5. If we wanted to group by several variables simultaneously, we just delimit them with commas. So here I've grouped by c and y. The grouping uses those two variables, and there are 4 different combinations. Those combinations you can see up here. There's the 1a, 1a combination, the 2b combination, 2a combination, and 3b combination. Those are all distinct. Otherwise, a tibble that's just grouped by more than one variable is just like any other grouped tibble. And the subsequent functions, as long as they're familiar with grouping operations, will perform in the way that you expect. Now, we've talked a lot about grouping. It's also important to talk about ungrouping. It's good practice to remove a grouping structure once you're done with it, because if you don't, you're going to forget it, and that could have consequences down the line. Here again is our first function call where we group a tibble and then we compute something on it. To ungroup the tibble, you just use ungroup at the end, and that will remove the grouping structure. It'll essentially just strip out all the attribute regarding grouping so that subsequent computations will not be done conditionally on some rows. It will be done over the entire tibble. Now, the last thing that we need to talk about is the row-wise function. Before dplyr version 1.0.0, row-wise effectively acted as a group by row, even though row was not, of course, a column in the dataset. The purpose of this was to facilitate an apply style operation where you're applying a function across different rows of the tibble. This was really before per array branch came into the picture and would work on data frames. Nevertheless, it never really worked quite as cleanly, I think, as people wanted, because the grouping still returned a tibble. In other words, the function that you're going to apply would then need to expect that the input of the function was a tibble as opposed to the actual variables in the tibble. And that was a little awkward. We'll revisit this when we discuss column manipulation, and in particular the mutate function. But you should know at this point that there is the row-wise function and that it's changed in some way in dplyr version 1.0.0. You can actually see this in the return value. Before, when you use row-wise, it will give you simply a grouped tibble back. So it says grouped by rows. And of course, as we said, row itself is not a column of the tibble, so it needs to say something else there. If you evaluate the same thing after dplyr version 1.0.0, you get this. It's still a tibble, but now it knows it's kind of like a special kind of grouped tibble called a row-wise tibble. As I said, at the moment, we can just think of this as a grouped tibble by row, and we'll see it a little bit more in action in column manipulation. So that's it for grouping. Grouping is a way for us to express the idea that we want subsequent computations done conditionally based on certain values in the tibble itself. It's a very powerful idea that we use absolutely all the time in practice, so be sure to take some time now to master grouping tibbles.